They say that fx is this things, and then fx is divided by this. They give us the quotient and the remainder respectively. So forgetting about this, from this we can build up fx by all these components. The key point is fx is equal to the quotient times the divisor and then plus the remainder. If you forget about this, maybe you can consider 13 divided by 4. 13 divided by 4, we get 3, and then we have the remainder 1. So 13 is come from two parts. The first part is the divisible part, 3 times 4. And the non-divisible part, that means the remainder. So that's why this is quotient. And then times the divisor, and then plus the remainder. That's how you memorize it. So to make good use of this information, we are going to write down fx in this format. Fx is equal to the quotient 3x plus 7 times the divisor, in this case 2x squared plus 8x plus 4, and then plus the corresponding remainder bx plus c. Even though there are lots of unknown here, we have 3 unknown constant, but however they give us this finalized answer, so we can compare their coefficient later on. It's the calculation of identity. But to compare with this, we need to write that down, how many x power 3 plus how many x squared plus how many x plus how many constant, so that we can compare term by term. So that's why we have incentive to expand it. I always suggest my student to separate to 2 rows if it is needed for clear presentation. Beware that x power 3 1 column, x power 2 1 column, x 1 column, constant 1 column. So, and then we compare with the given information here. From other point of view, fx is also equal to 6x power 3 minus 13x power 2 minus 46x plus 34. We can make our conclusion because they are exactly the same no matter what is x. The only possibility is every term are exactly the same. So we can write down our conclusion. This process is called by comparing coefficient. We know the first finding, 6 is equal to 6. 6 equal to 6 is rubbish, right? It may be useless, but we just write down all. And second finding is this term equal to this term. So 3a and then plus 14 should equal to negative 13. Oh, this one is better. It's because we have one unknown and not more than one. That's why it's easy to handle. So 3a is negative 27. A is negative 9. We just continue. From this term, 12 plus 7a plus b is equal to negative 46. 12 plus 7a plus b is equal to negative 46. It's because we already know what is a here. That's why we can continue the calculation. B is equal to 5. The last finding is 28 plus c equal to 34. So c is equal to 6. Therefore, we know a is negative 9, b is 5, c is 6. But in this question, they just ask you about a, so b and c may not be necessary. And then part b, we have a quadratic polynomials. So you should be more sensitive to this wording informations. Quadratic, that means is the highest degree is x squared. It must be this format. it can't be cubic. It's because they say quadratic. So when this is divided by this one, the remainder is bx plus c. It's similar to what we have done here. When it is divided by this, then the remainder is this one. So we try to build up what is gx. Gx is equal to quotient times the divisor, and then plus the remainder. Now the problem is, what's the quotient look like? Beware that we are talking about a quadratic divided by quadratic. If we consider x power 3 divided by x power 2, then we expect that the quotient will be x power 1 something. Now it's x power square divided by x power square. Then it won't be any x left, it must be a constant 1 here. So the key point is you have to let by the quadratic wording, you know that the quotient must be a constant. After we know more about gx, then we can focus on the questions here. What we concern is fx minus gx, so we just simply write that down. Fx minus gx is equal to, and then you have to think which kind of format of fx is this kind better or this kind of format is better. Then I will think this kind is better because I know some parts are duplicate and we have the factor 2x squared plus ax plus 4. So I try to explore in this way. Maybe it's not useful, but I tried this way first. And then after that, subtract these two items, k times of this, and then minus bx plus c, this remainder. So therefore you find that bx plus c and bx plus c here is cancelled out, and only two terms is left, and both terms we find a common factor, 2x squared plus ax plus 14. So we can extract the common factor, plus 4 only, and then we have 3x plus 7 minus k. If you can write in this format only one term, this time something, then that means you have enough evidence to claim that this is divisible by 2x squared plus ax plus 4. So therefore we make our conclusion. We finish part B1. In part B2, someone claimed that all the roots are integer. Do you agree? So we solving fx minus gx equals 0. And we know pretty well about fx minus gx is this bracket, these two brackets. So we have a we already know long time ago, which is -9. While we still don't know what is the exact value of k. It's because two factor multiply give you 0, so each factor may equal to 0. 2x squared minus 9x plus 4 may equal 0, or 3x plus 7 minus k equal to 0. Because we need to determine is that all of the roots fulfill the requirement are integers. So if any one of them is not, then we can simply disagree it. The key point is, I read it once again, I don't find any method to fix the value of k. K can be any value. So you may just use an example. If we get x equal to k minus 7 over 3 first, and then we just simply let some value for k. Let's say if k is equal to 3, if then x one of the roots will become 3 minus 7 over 3, which is negative 4 over 3, not integer. So that's why for some specific value of k, not all the roots are integers. That's why we do not agree. The claim. Of course, there are some suitable value of k will make it become integer, but they claim all the roots. So we just simply use one of the example which reject the situation. Then we can disagree the claim.